I'll be resuming today's class from our last lecture. I was telling you about the tree diagram, okay? So the tree diagram, if you remember, I showed you a tree diagram like this. A coin was tossed, okay? And you got head or tail in the first toss. Then you have head or tail in the second toss, okay? So I told you to label this tree diagram as much as you can, making sure that some of the probabilities on these branches has to be one. Okay, so you have the sample space like head with the probability 1/4, head tail with the probability of 1/4, tail head with the probability of 1/4, tail that is also 1/4. When you have this sample space, you will you would be happy to know that the sum of all these probabilities will also be equal to 1. Okay? Acha. Now this is a simple tree diagram. When we have like objects, we are choosing objects from a given set. Okay, like for example, there is a bottle or a container which has, suppose uh, there are 4 red balls, okay, and then there are, let's say, 6 green balls in that container, okay. So you're picking 2 balls from the container, and we have to show the sample space through the tree diagram. Guys, what information do you need before you go on to draw that tree diagram for this case where you're picking 2 balls from a container? Yes, a very important information is needed before you go on to draw those 2 balls and then draw the tree diagram. Anyone?
Sir, whether the balls are replenished or not?
Whether the balls are?
Replenished or not?
Yeah, exactly. We must know that did we replace the first ball before we pick the second ball, or we are picking the balls with replacement, okay? So that is the case. You people should be aware of that. Is it the with replacement or without the replacement wali situation? Now, suppose we are replacing the balls before we take the second ball. So the ball can either be red or green. Okay, so this is 4/10. This is 6/10. Though we can simplify these probabilities, but I would give you a suggestion that don't simplify these probabilities so that at a glance you can see that if the sum is 1 or not. Now, when you pick the second ball, you know that you have replaced the first ball. Okay, this is red, green. This is going to be 4/10. This is going to be 6/10. And this is going to be red. This is green. This is 4/10. This is 6/10. But so how many times we can repeat this experiment if we are replacing a ball before picking the second ball, the next ball?
Sir, endless number of times?
Yeah,
Infinite number.
we can do that for the infinite number of times. We can do for this for the rest of our lives until we are finished, or the balls are like they are just because of picking them again and again, they are gone away, like worn away. Okay, so you can do this as many times as you want. Okay. So this is also called the independent situation here. The probability of red is going to be constant throughout. Like, you see this is 4/10 here, this is 4/10 here, this is 4/10 here, okay? Your events are going to be, this is going to be red, the probability of 16/100. This is a red, green, that is 24/100. This is green, red, that is 24/100, and this is going to be green, that is going to be 36/100. Okay, I'm giving you a very simple example. My purpose is to make you recall what you have done in your levels. Now, suppose you are not replacing the ball um, once you have picked the first one, and when you're going to pick the second ball, you are not going to replace that. So the first experiment would have the same probability. This is 4 over 10. This is going to be 6 over 10. Okay. Now, suppose if the first ball was a red one, then when you're going to pick the second one, that means now the number of red is 3 and the number of green is still 6. Okay. So here the probability for the red would be 3 over 9 and this would be 6 over 9. And again, we can simplify these probabilities, but don't do that so that the sum remains 1. Okay. And you don't be confused when you go to pick the third ball. Okay. Now, this shows over here that the first one was green. So if the first one was green, then your second ball can be red or green. Okay. So this means the red are going to be 4, but the greens would now be 5 balls would be available if you're going to pick the second ball. And the first was green. So this is red, this is green, this is going to be 4 over 9. This is going to be 5 over 9. Now, this is a dependent situation over here. You see that if you look at the probability, for instance, you look at the probability of getting a red ball, it is 4 over 10 here. This is 3 over 9 here. And this is 4 over 9 here. All three probabilities are different. So this means the second experiment's outcomes probability depends on what is happening in the first experiment. Okay, and you make sure the sum remains 1 on these branches here. So this is your red, that is going to be 12 over 90. This is your red-green, that is 24 over 90. This is your green-red, that is 24 over 90. And this is your green-green, that is going to be 30 over 90. And you will see that the sum of all these is still going to be equal to 1 as the sum was 1 here. Okay, so that is how you people have been drawing the tree diagrams in your O levels, and this will continue here in your A levels as well. Okay, we have to talk about three things over here in your A-level probability. And I'm going to write them here and you make sure that you are quite crystal clear about this. First of all, about the independent events. Okay. Suppose there are two events A and B. If the probability of A and B that is equal to probability of A times the probability of B, that means the events A and B are independent events. Do you need any further detail about it or is it clear to you?
Um, Clear.
Okay. Now the second thing is the concept of a term which is called the mutually exclusive events. Like this is what being added onto your O-level probability, mutually exclusive events. Now there are two conditions. If any one of those two conditions are satisfied, that means the two events are going to be mutually exclusive events. First of all, if the probability of A and B that is equal to 0, it means that the two events are mutually exclusive, or if the probability of A union B that is same as probability of A plus probability of B. That means the two events are going to be mutually exclusive events. Like in normal terms, in common terms, in simple words, it means that the two events, they don't have anything in common. Do you need any further detail on to it? Yes or no? There is no sound, so I'm going to move on to the
No, sir, it's fine.
Okay, thank you, beta. Now we are going to talk about the conditional probability. Okay. Now there is a formula for this conditional probability. It is written as probability of A given B. That is going to be probability of A and B over the probability of B. Let me make it clear to you in my Desi words, Desi terms, and then we'll be trying this to the formula as well. Okay. For this, you have to take an example over here. This has been a question in your past papers as well. Okay. Now, in a sample, there are men and there are women. Okay. There are employed men and there are unemployed men or women. Okay. Now, suppose uh, there are 20 employed men, there are 50 unemployed men. There are 70 employed women, there are 30 unemployed women. Okay. And total, there are 90 employed people, there are 80 unemployed people. They are altogether 170. Now these are there are 70 men and there are 100 women. Okay. ठीक है बच्चों? So this is the given information to you. Now, suppose the question is, you have to give the probability, you have to find the probability. You choose a person from all these 170 people over here, okay? And the question is, what is the probability that the person chosen is an employed man? Is an employed man, okay? So probability of employed man. This is employed and man, okay? So, how many employed men are there?
20.
20. And how many people are there? 170.
170.
So that means the probability of picking an employed man from these 170 people is going to be 2 over 17. Okay? We pick Now, we pick a person. Now, don't assume that we have picked a person and now we're going to pick from the remaining 169. No, this is not that, okay? Not like that, okay? Now, we pick a person from all these 170 people over here. What is the probability that the person chosen is an unemployed woman?
Sir, 30 over 170.
That is 30 over 170. So that is going to be 3 over 17. ठीक है? अच्छा बच्चों. Now, suppose if I ask the question, let me write it down. Given that the person chosen is a man, find the probability that he is employed. Okay? So the question is, given that the person chosen is a man, find the probability that he is employed. Now that is the question. So when we are given a condition over here, it says given that the person is a man. So that is a condition. And we have to find the probability that the man is employed. So in probabilities terms, we'll write it as finding the probability. Let me erase this. Finding the probability of employed given man. Okay, so this is my Desi method now. Rather than looking at all these 170 people, You will be focusing on the men only. You will focus on the men only. Okay? Like when we were finding these probabilities here, we were finding them from all the 170 people. Now, when it says given if the person chosen is a man, so you're going to limit your data, which is all about the men. Okay, guys? Is it very difficult thing to focus on just the men? बेटा जल्दी बताओ.
नहीं सर.
We're going to limit our
No, sir.
population. We're going to limit our population from 170 to only these 70 men over here. And now from these 70 men, we know that 20 of them, they are employed. So this would be 20 over 70. So that would be 2 over 7. If I use a formula for this, the formula says probability that of finding E given M is going to be probability of E and M over probability of M. Now look at this, you will get the same answer. Now what's the probability from all of this population of getting a person who's employed and male? So we have already got that. That is going to be 2 over 17 or 20 over 170. Yes, 20 over 170. And what is the probability of picking a person who is a man? So that is going to be 70 over 170. Please stop me if you think that something is going to be go beyond your imagination. Okay, so if you simplify this, you still get the same answer, that is 2 over 7. Now this is totally up to you. If you use the desi method like this, like limiting your all this information or the data up to this condition, which is like given that blah blah blah. Okay, and then you find this through the desi method, or you can use this formula as well. Okay, now let me ask you a question here. Now the question is that you have to find the probability. Let me just make some space here. Okay, I should write the question here. Okay, now the question is uh, given that given that the person is employed, okay, find the probability that the person chosen is a woman. Okay, try this question. I'll be
So
asking.
7 over 9.
Over 90.
7 over 9. 7 over 9.
7 over 9. Okay. So mashallah, you people are really genius. You see, this is one of those topics where the students are always complaining, sir, conditional probability samajh nahi aayi. You see, first of all, you must learn how to write it down. Okay. You will be saying, okay, given that after the slash, this comes given that wali condition. Given that the person is employed, find the probability that the person is a woman. So this is find the probability of choosing a woman given that she is employed. Okay, so this is going to be like you just focus onto this, all these employed people. Okay, so there are 90 employed people, and out of these 90 employed people, there are 70 women. So that is 7 over 9. If instead you try this through the formula, so please, you must know this formula as well. Okay, the formula says to find the probability of women given employed. So this is going to be probability of women and employed over the probability of employed. Okay, so women and employed, that is 70 over 170, and employed is going to be 90 over 170. So you can cancel the 170 with the 170, and you're left with this 7 over 9. Is this clear to you, bacho?
Yes, sir.
Yes? Okay, now I'll be taking you to the past papers. I'll not be doing any question from the book, okay, because this will really take long. So the questions from the past papers would tell us if this is clear to you. So moving on to the past papers. Okay, guys.